Okay, a lot of people have trouble whenever they're given an expression and they are asked to simplify. Simplify means to try to break this down as much as possible. And if you are given a radical that is a different index than 2, a cubed root, fourth, fifth, it becomes a little tricky. So here's how I would do it every single time so that you're not being inconsistent and messing up. My first step is to always use the rule about how to rewrite. Now that rule, I'm just going to draw it real quick. That rule looks something like this. If you have an index and you have an exponent down here, you can always rewrite it by turning it into a fraction exponent. So most people have seen this if you're attempting one of these problems. So I'm going to do this rule with the above problem. So basically I'm going to take the 27 x to the third y, group it in some parentheses, and then I'm going to pretend that the exponent on all of this is just a 1, since I don't see parentheses already there, and so that becomes a 1/3 when I move it to the outside. Now what I do is, in my brain or physically on paper, I need to distribute this power to all three things that are on the inside. So my next step would look like this: 27 to the 1/3, and then x to the third to the 1/3, and then y to the 1/3. Now notice I grouped this in parentheses because it had an exponent other than 1 on it, and I want to make sure I don't forget that. So the next thing I'm going to do is go through and simplify this. So 27 to the 1/3 power, you should hopefully somewhere you have written out all of your roots, so that if you're dealing with, maybe you have a paper where you've written down all the numbers that are squared, which most people know these, but then maybe you've also written everything to the third power. And this is the list that you need, okay? So 2 cubed is 8, 27, 64, I think that's a 125. Okay, why do you need this list? Well, because if you're going to the 1/3 power, it's the same thing as the cubed root, right? I mean, that's where we started from. So if the 27 shows up on the cubes, then you work backwards and you pull the 3 out. So basically, you've just simplified this whole number by using your chart full of numbers. Now, what's the rule when you have a power to a power? Well, you multiply, and a 3 times a 1/3 is just a 1, and then we have y to the 1/3, and that, we can't simplify that. So depending on what your teacher likes and what your directions say, the answer is either going to be this, okay, or some teachers don't like a fraction exponent. So anything that has a fraction exponent, you need to go back and write it as a radical. So the 3 and the x, those don't go underneath because they have exponents of 1. So they're safe to say on the outside. But this y to the 1/3, you would go back and rewrite it like so. So me personally, I like that. But talk to your teacher because they may be okay with that, and that's a little bit easier for where to stop. All right, so let's try another one of these that maybe doesn't clean up as nicely. How about, okay, excuse me, so just like I did before, with something like this, you look at what root you're dealing with. So this is the 5th root. So I would look at all my numbers, 2 to the 5th, 3 to the 5th, 4 to the 5th, when what you're hoping for is that something shows up. Now, even though 192 is not on your list, one of these numbers goes into 192. So we're going to be thinking about that as we rewrite it. So the first step I told you is to rewrite it as the 192 r squared, and then all of it to the 1/5 power. Now we're going to distribute the 1/5 to the inside of each one, r squared 1/5. Okay, great. So now I'm going to work on the number separate from the variable. So what I'm going to do is think, okay, is there a number from this list that goes into 192? And the answer is yes. 32 goes into this 6 times. So then I'm just kind of rewriting it. So what is the 5th root of 32? Well, if you look over here, it breaks down to a 2. Now, this is still left over, right? right? So I have a 2 here, but I need to recopy that 6 to the 1/5 because it doesn't break down, okay? Now over here, what's the rule with a power to a power? Well, you multiply. Awesome. And so this right here is one of my answers, but usually, like I was saying, I like people to go back, and I don't like fraction exponents. So what I would have them do is, the 2 right now, what's the power on 2? Well, it's a 1, so it gets to stay as is. But this one and this one, you can go back and write as like the 5th root, okay, because both of them have a 5 on the bottom. So this will be 6 to the 1st and r squared. And it would just stay like that. So you don't have to write, remember, you don't have to write the little 1 right there. So this is the answer that I would like for my students to simplify. So let's try one where we go the opposite way. So maybe you're given something as an exponent, and you have to clean this one up. Okay, so what I would do, first thing is the negative exponent is bad. So I would move this entire thing down to the denominator, because you should have learned that that's what a negative exponent does. Now, even though it's underneath 1, I'm going to distribute the 3/2 to both terms. So I'm going to have 16 to the 3/2 and then m to the 6th to the 3/2. Now, let's try to figure out this number here. Well, remember, the way that this works is the denominator is what root you're taking. So what is the square root of 16? Well, the answer is 4, right? 4 is the square root of 16, and there's still that 3 left over, so I'm just going to recopy it, okay? Now, what is 4 to the 3rd? Well, that's 4 times 4 times 4, and I believe that's a 64. So this is turning into a 64, and I've already handled all of that. Now we're going to distribute the 3/2 to the 6, so we need to multiply. So that'll be m to the 9th, I believe. Let's make sure. Yeah, that's right. Okay, and that's it. There's no negative exponents. There's no fraction exponents. I'm going to call myself done. All right, so try a few and let me know if you get stuck, and that's it for now.